In the interests of Paul actually being able to give his talk, I better keep this brief. But it is my distinct pleasure to introduce Paul Clements, who is really one of the pillars of the software architecture community. He's written several books. I used to teach software architecture at the University of Minnesota, and one of the most important textbooks was Software Engineering in Practice, which he co-wrote with Rick Kasman. And he's also written books on software product lines, on documenting software architectures, and these books form the basis of software architecture as a rational discipline. One of my colleagues in graduate school, Jeff Thompson, wrote his dissertation on product lines, and a lot of it was structured based on Paul's work in his book. Not only has he written a lot, but he's formed communities. So he is a founding member of the IFIP Working Group on Software Architecture, is the first general chair of WICSA, the Working International Conference in Software Architectures. He's applied his trade both academically very successfully here at ICSE and in other venues, but also in industry, where he's the VP of Customer Success at Big Lever Software. And I would tell you more about that, but I'll let him do that. So let's give a warm ICSE welcome to Paul Clements.
Is that me? There we are. Thank you, Mike. That was very sweet of you. I appreciate that. It's very nice to be here today. My God, there are a lot of people in this room. I hope I will make it worth your time. I don't know the word. It's an experience to hear your career summarized in front of you. And I think if I could encapsulate it in some way, it's dealing with things that change. And so this is going to be the theme of what I want to talk about this morning. The talk is Managing Variation, an industrial perspective on product line engineering, which is a subfield of systems and software engineering that is about managing change and variation. This is Heraclitus of Ephesus, who said a long, long time ago, about 2.5 millennia ago, that everything changes, nothing remains the same. Much of what he wrote was noticing that things changed. Change happens. One of my favorite quotes from him is that no man can step in the same river twice. Isn't that great? I wish I were clever. I think that's such a wonderful quote. And I think he got it right. And so for us to take that observation and put it into practice, I believe requires us to recognize that in order to make our products enduring, we need to recognize that change happens. And I choose to work on products that are enduring. I just choose that. If we don't do that, then our work, I think, will be discarded, because when the inevitable change happens, they will no longer be appropriate, and they will be discarded and thrown away. That's expensive and wasteful, and I think that's an objective observation. But to me, it's also sad, and that's admittedly a subjective observation, but nevertheless, I think it's sad. I think if we are given the choice, and we usually are, then we should work on things that endure and not things that are transient. And so in thinking about change, it occurs to me that there's two ways to think about it. One is to think about change in terms of a window of time. So we have a system or a solution today, and someone comes along later and says, I wanted to do something different. And you say, no problem, I'm on it. So a year from now, it needs to do something different, and 6 months later, it needs to do something different still. 6 months later, it needs to do something different still. This is a linear progression of your system solution over time. And that's fine. That's a lot of what we do, and that's okay. But to me, things get interesting when we shrink that time window to zero. Your system doesn't need to do something different a year from now. It needs to do something different in addition to what it already does right now. And this is the area of system engineering in which I will spend the rest of the talk this morning. What if the time window goes to 0? Our solution needs to do and be many different things right now. What are a couple of ways to proceed on that? First is you could say that, well, let's make a general solution. Let's build a single thing and let's make it do everything. Well, all right, at this point in my talk, I knew I was going to have this crisis of confidence because I really like that. I would really like us to build that. I think that would be the coolest thing ever. However, I'm going to soldier on and say, no, that's probably not the most sensible thing that we could do, to strive for a system that does everything, a single system that meets all of the requirements for many different stakeholders. Sometimes you can do that, and that's fine. If you can build a system that's general, that's great. But in the world in which I live, creating that general solution is harder than it sounds, especially for complex systems. And this is why, if you look around, we don't have just one type of aircraft. We don't have just one type of ship. We don't have one type of automotive vehicle. We don't have one type of light bulb. We don't have one type of chair. If you look around us, you can see all of these families of solutions, because the single general does everything form doesn't work. We build separate systems that serve different needs and markets. And this is the world in which I breathe these days. And I'll be curious to see what you think about that as well. It seems to me that most product development organizations deliver a product line, which is a portfolio of similar products or systems. They're similar, but they're different from each other. They're not copies, they're different, with variations, and you can characterize those variations in terms of their features and their functions. So look at the first 4 words of the slide. It seems to me. Does it seem to you, or is this just the air in which I happen to find myself breathing? How many of you work for product building organizations? Show of hands. How many of those organizations, those people who are raising your hands, how many of your organizations build product lines? Okay. All right. Yeah, quite a lot. Quite a lot not, I guess, and that's okay too. I think most of us were taught how to build a single system. I was. Does this match your experience? How many people were taught to build a single system at a time? Here's how you build the system and you do it the best you can. Yeah, me too. Me too. Does anybody here feel like in their educational trajectory they were taught how to build a product line? Really? Oh, God bless you. Okay. Okay, you and you and you. All right, so the 3 of you. Oh, you, thank you. Lovely. Wow, that's great. That makes me feel good. But I think we can agree that's a minority, and I think that's well, that makes me sad. Because I think this is the normal case. I think this is the case that most of us find ourselves when we launch out of our academic career and into our industrial career. At least that's what I observe. So product line engineering, let me give you a definition that I hope you can take. I've already defined product line. The form of product line engineering I'm going to talk about is this. It's the engineering of a product line. Well, don't fall out of your seats at that. No surprise there. But here's the cool part. It's using 3 things. A shared set of engineering assets. This is the International Conference of Software Engineering, but in the world in which I work, software is but one kind of asset that people deal with. They also deal with requirements and tests and designs and models and simulations and bills of materials and parts and lots of things in addition to software, sometimes not even software at all. Sometimes software is not even on the table. And so by shared assets, an asset, what I mean is anything, any engineering artifact you use in the conceptualization, creation, design, implementation, operation of your system's solution. So we're going to be very general here. I'm going to push the boundaries beyond software, although this is certainly the community in which I grew up. Shared set of engineering assets. The third thing is a managed set of features. So the form of product line engineering I want to talk about eventually is feature-based. A feature is a distinguishing characteristic. It's something that sets this member of the product line apart from this member of the product line. In the automotive world, we order features, right? I want a sunroof. I want the fancy infotainment system. I want the big engine. I want the powerful brakes. Or I don't. So all of those are features. They are distinguishing characteristics, something that sets the members of my product line apart from each other. And that is, I think, a new ingredient. That's where we start to learn to build a product, how to build a product line as opposed to a single system. The notion of a feature as a discriminating characteristic makes no sense if I'm just interested in building the solution of the day, because I'm not distinguishing between or among any things. And finally, an efficient means of production. I'll talk more about that later. Product line engineering is an approach to take advantage of the commonality shared across the family. These are not totally different systems. They're similar, and we're going to use that similarity, and we're going to take economic advantage of it. But we're not afraid of variation. We love variation. We're going to effectively and systematically manage that as well. So in my world, products can include any combination of software only, or systems in which software happens to run, or non-software systems that have digitally representable assets like requirement spec and parts and bills of materials and things like that, designs, blueprints. Well, this is a good idea, and it's been around for a long time. The earliest example I know, if you know an earlier one, please tell me, I sort of collect these, comes from the 1st century BC, and it's Roman statues. If you were a semi-well-to-do member of Roman society, one of the things that you could do to show off your place in society was have a statue of yourself made. Well, the organizations, or I'll call them companies, that built these statues came across or hit upon a very productive idea. They said, we'll just build a ton of bodies, and they'll be all the same, and we can have the low-skilled craftsmen do that. But then when a customer comes into the studio, we'll have them sit and we'll sculpt their head. And then we'll put the head on the body. Well, that's a product line. I love it. The variation is the head, but the normal part, the reusable part, if you will, is the design of the body. This, what I'm showing now, is a Roman theater at Orange, which is now in France, and it's a statue of whoever the hell was emperor at the time. I don't know. When the emperor changed, same statue, different head. I think it's a great product line. I love it. Here's another one I really like. In 1103, the state architect of the Chinese imperial kingdom published a set of building plans for imperial buildings. And he published sets of building codes and designs and ornamentation and parts, and he made designs parameterizable, although he would have had no clue what that word means. I can barely say it. And you could tell, he wouldn't have known what this meant either, but you could tell he was after a product line of buildings. So the basic designs were the same, but the ornamentation, the structure, the actual dimensions could vary. I think it's a lovely example of a product line. I hesitate bringing up this example because it's going to be irresistible to ask this question. Does anybody in this room remember these? Oh, that's nice. That's nice. Yeah, me too. The IBM System 360 was a family of computers, and it was one of the earliest examples of a family of computers designed to be a family of computers. And its operating system was a family of operating systems designed intentionally to be a family of operating systems, reusing and sharing commonality where we could, but making extensions in different ways. So this is from the Principles of Operation. And I've still got my copy someplace. It's in a box. I don't know where, but I've got it. Models of System 360 differ in storage speed, storage width, register width, the capabilities for processing data concurrently with the operation of multiple input and output devices. Several CPUs, several different CPUs, permit a wide choice in internal performance, yet none of these differences affect the logical appearance of these models to the programmer. They all use the same instruction set. And here's my favorite. An individual System 360 is obtained by selecting the system components most suited to the applications from a wide variety of alternatives in internal performance, functional ability, and I/O. That's a product line. The System 360 Model 30, it was a very, I'll say, low-end member of the family. It's very economical. It was very affordable compared to some of the higher-end ones. It didn't have performance that was like the other computers. And that's because IBM actually added extra instructions in the microcode to slow it down. You can either decide that's a good idea or not, but there you go. So I think that's a lovely example of a product line, a little bit more in, at least in the memory of some of us. This is one of my favorite examples. In the 1980s, Boeing developed the Boeing 757 and 767. Neither of these aircraft are still in production. But Boeing did something that was innovative at the time. They designed these two very different aircraft together at the same time. And they're really different. The 757 is a single aisle, sort of intermediate range aircraft. The 767 is a double aisle, twin aisle, long range aircraft. Boeing designed them to share as much as they could. So some 60% of the parts inventory of these two aircraft, it's identical. The flight decks are identical. If you could fly the 767, or either one, I should say, then you could be certified to fly the other one by spending an afternoon in a simulator. Think about the savings. Parts inventory, if you're an airline operating these two planes, the number of parts you have to have on hand just shrinks because 60% of your inventory now can serve either kind of airplane. Think about the training costs reduced. Think about the crew scheduling advantages that comes with. I think it's I like it. I think it's a very innovative way to build airplanes. Now, I distinguish this from the notion of a product line where airplanes are just longer and shorter versions of each other. We've been doing that since the 30s and 40s, 1930s and 1940s. That's not what this is. These are two very different airplanes. So the Airbus family of jets, 318, 319, 320, and 321, essentially longer and shorter versions of each other. And yes, they're a product line, and yes, the same crew can operate any of the aircraft and so forth. But that's different. So, in my look back on the product line engineering field in the 1990s and the 2000s, people started to understand that there was something afoot. Case studies and anecdotes and stories and published papers started to tell the story of innovative companies that did not just build a single system and decide that that was what they were going to put out into the world, but they built families of systems. They built product lines. And they were showing some extraordinary numbers as a result of it, managing variation. I wrote my first product line case study in 1995, I think. Is that right? Maybe? I don't know. Anyway, a long time ago. And it was about a company in Sweden, and the company's name was Celsius Tech. I think they've been swallowed up by about 3 other companies in succession since then. But they built very large shipboard command and control systems for Scandinavian navies, also Australia, New Zealand navies, I think a couple of Middle Eastern countries as well. And in December of 1985, I believe it was, their salesmen came home to headquarters from 2 different directions, each having landed a larger sale than the company had ever built before. Should be good news, right? In fact, the leadership at Celsius Tech clutched their chest and fell out of their chair in a dead faint. They said, we will never be able to build both of these systems. Our company is doomed. We cannot do this. And so they put their lead thinkers in a closet, almost literally, for about 2 weeks, almost literally, the pizza boxes piled high. And their job was to come out with an architecture that would satisfy both of these 2 new ships, new to Celsius Tech. And they did. And with the architecture came, as you can imagine, the identification of components, which were programmed. And to the extent that the components could be used on both ships, they were. This is the software analog of the Boeing 757, 767 story. And they were. By the time I got to Celsius Tech and wrote the case study, they shared some of these numbers with me. They said when we first started, before we started our product line approach, we had 200 software engineers. Now we're building more systems than we ever did before. Our total staff of software engineers is 30. The systems are bigger and more numerous. They said it used to take us 7 years to build one of these systems. Now we turn them out in 2. And so I went over there to gather information about a case study on architecture. I thought, I want to see what architecture is that they're using. And a colleague of mine had said, you're collecting architectures to write about. I know somebody who designed an architecture for a purpose that you haven't thought about. And I was thinking about high performance, high security, high reliability, modifiability, all these architectural quality attributes. I said, what purpose of an architecture have I not thought about? And she said, to support a product line. And I said, wow, that's great. What's a product line? And she told me, and I said, well, they talked to us, and she said, they will. And I said, where are they? She said, Stockholm. And I said, when do we leave? And so they were very sweet. They told us all about this, and their architecture was, it was fine. It was layered, it was publish, subscribe, it was kind of client server, it had some central repository flavors to it. It was fine, but it was uninteresting compared to, we used to have 200 people, and now I can do more work with 30. And so I realized there was something going on here, done by people smarter than me. And so case studies like this began to emerge. Books came out, and I think what I've learned about product line engineering is that there are two fundamental approaches. One is that you can build the members of your product line with copying. I'm adding a new member to my product line. Okay, find the most similar one, make a copy of it, and go to town. And there's another way you can do this without copying. So let me talk about the first way, with copying. Many of the old or first generation approaches to product line engineering discriminate between core asset building and product building, or discriminate between domain engineering and application engineering. So domain engineering, the Software Engineering Institute called it core asset building. Domain engineering means build all the reusable stuff. And the other side of that, whether it's application engineering or product building, means go check out the reusable stuff and reuse it. And while you do that, you have license to make any changes that you need in order to build the member of the product line that you're working on. But it's awesome because you're so far ahead. I didn't need to build the reusable thing. I just checked it out, and that took me a long way down the path. Pretty good. But it's reuse with copying, largely. It's reuse with copying. Come back. The problems, I think, with the early approaches were that they emphasized software. In my trajectory through this world, product line engineering grew out of software product line engineering. It was about the reuse of software. That was a limitation. As I've already mentioned, we're going to expand the scale. People work on things besides code. They want to reuse and exploit the commonality among other kinds of engineering assets that they have to build as they're turning out these systems. Automation was welcomed in all of the literature, but nobody had an idea of what it should look like, and so there really wasn't any. And the approaches were mostly based around copy-based reuse. Not awful, right? It's not awful. It's not awful. If it's all you know, then it looks pretty good. And the numbers were astonishing, these, you know, some of which I've shared. But my big complaint about the early approaches was that there was no clear, prescriptive, repeatable methodology. Everybody had a different approach. One of the actually better books, I think, is software, screen's not up here, was Software Product Lines in Action, and it's basically a book of case studies. Here's how a lot of different companies built successful product lines and had these wonderful numbers. I thought it was a great book of case studies. I really liked it. Okay, I wrote the foreword for it, but I really liked it anyway. But I didn't know what to do with what they were telling me. I didn't know how to repeat that. But still, big numbers. So here's what I've got against copying. The reuse among products is, let me go back one. Typically, when there's a copy reuse-based approach, this is sort of the extreme form of that. Organizations build silos, one for each member of the product line, or maybe one for each couple members of the product line. They're different teams. So in this diagram, blue shirt guy up there at the top left, he goes to work every day and he works for product A. And he comes home at night and the family says, "How was your day?" And he says, "It was okay." And they say, "What do you do again?" He goes, "I do requirements for product A." And the family says, "Is that fun?" He goes, "Oh, okay, it's okay." And so forth. So everybody does that, and there is reuse among the teams. It's often not systematic. It's often based on borrowing, which is a quaint word. Borrowing means I'm going to take it and not give it back. You know, it's software or documentation. It's digital, right? So I'm going to make a copy of it and keep it. And it just doesn't tend to scale very well. The borrowing can be anything: budgets, plans, object frameworks, test cases, user's manual. I mean, it goes on and on. And it's very hard to untangle that. Suppose product B has a defect. Suppose it came from product B's requirements. We can trace it back to the requirements. We got the requirements wrong from day one. So the testing team in product B discovers it. The requirements engineer in product B says, it's me, I'm sorry, you're right. Well, team B can fix product B. All right, no worries. They're professionals. That's what they do. We love our jobs. However, where did that come from? If product B was actually instantiated through borrowing and reuse and copying, what's the pedigree of that defect that they're now sorting out? It could have come from product A, in which case it's A's fault, and poor requirements A person has no idea there was a problem. Anything who borrowed subsequently from product B, they're now in the swamp as well. They don't know what to do. Many organizations try to CM their way out of this, and it's a lot of branching and merging and merging and branching and more merging. And their best, highest skilled engineers, the people who should be inventing new, innovative solutions, are spending their time copying and branching and merging. And if you sort of do some arithmetic on this, to really sort that out, if you haven't kept track of it carefully up to this point, every team kind of has to talk to every other team to say, were you impacted by that? And that's n teams talking to n-1 other teams, and that's an order n squared kind of communication overhead. Well, still better than building from scratch. But let's see if we can go to a higher level. Let's talk about building a product line without copying. Around the turn of the century, automation started to appear on the scene. This automation that was always hinted at in the earlier approaches, but never seemed to make its way into reality. Commercial product line engineering automation made its way onto the scene. The company I work for provides some, there are others as well. And modern product line engineering strongly embraces the factory paradigm, and I'll tell you what that means. And this is building a product line without copying from one solution to another. This is what a PLE factory looks like. Now, this is a conceptual construct. It's a metaphor. Sometimes I go into organizations that actually do manufacturing, and I say, we're going to build you a PLE factory. And they go, no, we have factories. Thank you. They're great big buildings. I go, no, I'm sorry. I didn't mean that. It's a conceptual thing. So here are the parts of a PLE factory. I'll give a little bit away at the beginning. The automation is the thing sitting right there in the middle in the blue box. Gears is the name of the tool my company builds, but never mind. Here are the parts of the factory. Here are those shared assets that I talked about before. They come into the factory as inputs. They can be anything you like. The usual suspects include things like requirements and specifications and design models, certainly software code, if there's software involved, test cases, bills of materials, maybe calibration files. Did I say test cases? Certification, documentation packages. That's an engineering artifact we have to deal with if I'm dealing in a certification environment. So all of those things come into the factory. The second thing that comes into the factory is a construct called a bill of features. This is a takeoff on the term bill of materials. Anybody who's built a house or any physical system knows what a bill of materials is. It's a parts list. And so I have a bill of features instead. And this is a feature-based description of a member of the product line. It's what features it has. A different member of the product line will have a different bill of features that describes it, because it's different. The bill of features between two products may be similar, but they'll be different because the products are different. That comes into the factory as well, and this is where the automation takes over. The automation puts the two things together, and what happens is that features come in, assets are configured, and a product comes out. And by product, you know, I don't mean a car or an airplane. I mean the digital instantiation of the assets that comes out. And so you can do this all day long, feed in a different bill of features, and you'll get a different set of asset instances. Feature model, Here, well, I don't know, why not? This is what a typical feature model looks like. We represent ours as a tree. If you read about, in the literature about feature models, many people represent their features as a tree, and so this represents a set of choices that you can choose from. This is a feature model for a power door locks system for a car. And over on the left is a box called lockout deterrent. And lockout deterrent, in the world that this example came from, this is a feature that tries to keep you from locking your keys in the car. That's nice. Those of us who have lockout deterrent have probably all been saved by it at one time or another. If you have it, if you leave the keys in and go to get out of the car and push the lock button, the car won't lock, it will beep at you instead. But it's optional. You wouldn't maybe put that on every member of your power door locks product line. You put it on some. Lock status indication, request source, all of these are distinguishing characteristics about, in this case, a power door locks system. This feature representation, this is just the distinguishing characteristics of the members of the product line. It does not talk about requirements or code or specs or designs or test cases or bills of materials or certifications or documentations or user manual. This is an abstraction of capabilities, and this is what a feature model does. I'll share with you some organizations who are doing the thing that I have described. The first is Lockheed Martin. This is the largest defense contractor on the planet. Their showcase product line, and they showcase it, they've published a lot about this, and it's on their website as well, is the Aegis weapons system. Aegis, as you may know, is a command and control system that serves on about 100 ships worldwide, mostly in the US Navy, but not all. Some other navies have Aegis platforms as well. And with product line engineering, Lockheed Martin manages their requirements, about a couple of 100,000, between 1 and 200,000 requirements objects, and a few million lines of source code. So those are their shared assets, requirements and source code. And they don't build 100 copies of these things, one for each ship. They build one copy of each of these things, and they build them as a superset of requirements and a superset of source code. And the automation, the configurator, instantiates those to each of the 100 ships. So imagine 100 copies of a couple million lines of source code. Imagine 100 copies of 1 to 200,000 requirements. Think about the people that you have to have in place in order to work on those, manage those, maintain those, manage the evolution of those if you have the courage to try to manage all that collectively, as opposed to just letting each member go its own way. That's what Lockheed Martin walked away from. They said, no, we're not going to have separate copies. We're going to have a single copy. This came about because before they went to this approach, a defect would show up on a ship. That happens. And so Lockheed Martin would happily go fix the defect and bill the Navy. And then the same defect would show up on another ship, and Lockheed Martin would go fix that and happily bill the Navy. And it wasn't too long before the US Navy sort of stopped seeing the humor in that situation. And they said, we need you to do something different. And they went to this approach. The Navy and Lockheed, they don't call this product line engineering, although they know it is. Their motto for it, their mantra for it is fix it once, because that was the need that this solved. In the early days, the Coast Guard was building an Aegis platform. It's the Coast Guard, their ship is called the National Security Cutter. And it's an Aegis platform. It has part of the Aegis weapon system on it. And the Coast Guard said, we need to build a requirement spec for our ship. May we borrow yours? And you know exactly what they were going to do. They were going to make a copy of it and go off, make changes, never talk to the Navy again. And the Navy, to its credit, said, don't do that. Don't do that. Coast Guard, come join the Aegis family. And the Coast Guard, to its credit, said, what does that involve? And the Navy said, tell us the features, the Aegis features of the National Security Cutter, and we'll generate the requirement spec for you. Well, the Coast Guard said, that's pretty good. You may or may not know that the Coast Guard and the Navy are in two way separate departments in the United States government. And man, there are watertight compartments between various branches of government in the U.S. Coast Guard is part of Homeland Security, where the Navy, of course, is part of Department of Defense. And so to get these two different organizations to work together was a minor miracle in and of itself. But the Coast Guard said, fine, we'll do that. And they had allocated 3 to 4 months to get their requirements spec'd down, and they had it baseline in 2 weeks. Now, if you'll let me do a little simple-minded arithmetic, that's an 8-to-1 improvement. And that's the kind of number I've sort of gotten used to. And not a 20% improvement, not a 40% improvement, not a 50% improvement, an 800-time improvement. We see this over and over again. So I've become a fan of this approach. I think there's really something going on here. This is another example. This is another U.S. defense contractor. When I grew up, U.S. defense contractors were pretty stodgy organizations, but it turns out that many of them are actually being very innovative and adopting this approach. I know that at least 5 of the top 10 defense contractors in the world are doing this. This is one, as is Lockheed, that I can tell you about because they've published. They're quite proud of this. This is General Dynamics. They are, depending on which source you read, up to the number 3 defense contractor in the world. Their showcase product line is called Live Training Transformation. And it's a product line of training systems for mostly the U.S. Army, some other services as well. So training systems, this product line is one of my favorite because its breadth is so wide. At the low end of the product line, kind of a small system, a single warfighter will walk up to a target with his or her weapon and take target practice or weapons qualification training. And there's a camera, and the target is instrumented, so the system scores, it records, plays back, generates an after-action report. Great. Okay, now move up the scale of scale a little bit, and it's not just a single warfighter, it's a squad. And so a squad will take weapons qualification training. Okay, move up a little bit more, and it's a crew of a vehicle. It's a crew of an armored vehicle or a tank. And now the shooter is on the move, and they're firing at lots of different targets. Well, same deal. The system scores, records, because the targets are instrumented, scores, records, there are more cameras, plays back, builds an after-action report. All the way up to the high end of the scale, I have brigades and battalions, thousands and thousands of soldiers running around fields shooting at each other with lasers. And they're wearing laser detectors on their uniforms, on their fatigues, and the system does the same thing. But now there are dozens and dozens and dozens of cameras, and this takes place over many square miles. But the system does the same thing, just at scale. Millions of lines of source code. General Dynamics manages their shared assets, which are source code, but also some innovative things, documentation and parts. These systems, when they're deployed at a training range, they show up in shipping containers. And the right stuff has to be in the shipping containers. Computers and racks and cables and uniforms and laser vests and laser rifles and cameras and more cables. And if a simulation, a training exercise doesn't take place because I'm missing a cable, because I forgot to pack it, that's $1 million a day, and nobody's happy about that. And so that's what they manage with this approach. What I didn't tell you about Lockheed Martin, because I just forgot, they have calculated that they're saving $47 million a year with this approach, each and every year. General Dynamics says over 12 years, we've saved about $830 million over 12 years. That ain't nothing. We're getting on up to $1 billion worth of savings. I mean, again, the numbers are just pretty big. I'll just do one more for you. This is General Motors. General Motors has been building a product line for decades and decades. Somewhat unique in the auto industry. General Motors doesn't view what they build as separate product lines. They view everything they build as one single product line. Now think about that. General Motors builds great big delivery trucks and the Corvette and electric vehicles and everything in between. To GM, the great big lumbering delivery truck is exactly the same as the Corvette, except for all the ways in which it's different. And so what General Motors is learning to do now is to capture those differences, those distinguishing characteristics, those features. They've been learning to capture those in feature models. General Motors is bringing to the table requirements, test cases, models, design models, And more things as well. One more thing that I'll tell you about. Generally not software. Generally not software. It turns out that most of the time, every single car comes down the assembly line, they get the same software on it. It's just too time-consuming to load up a chip, or to load up all the chips, to load up the chipset with software that's unique to a vehicle. And so every car, the chips come preloaded from the factory. Every car gets the same software. But what they can put on a car in the time it takes it to roll down the assembly line is a calibration file. Calibration file is a file of zeros and ones. It turns on certain functionality, it turns off other functionality, and that is unique to a vehicle. GM builds about 30,000 electrically unique configurations. So that's how many different types of cal sets they need. And a car might have 10,000 cal parameters on it. So do the combinatorics of that. GM, until recently, the way they built all those calibration sets for all of their vehicles was with spreadsheets and lots of people. There are days when I really like my job, and there are days when my job is stressful. But I really like my job more than whoever it is that sits down in front of a spreadsheet all day, turning on zeros and ones for cars. God love those people. They need some love, I think. Well, under this product line engineering paradigm, if you're able to capture the distinguishing characteristics of a specific vehicle, then that factory metaphor I showed you before, one of the instances that it can output is the calibration file for that vehicle. So General Motors has done the arithmetic on this, and they expect to save in the neighborhood of tens to up to $100 million annually just from that. Never mind their requirements, never mind their designs, never mind all the other stuff, their test cases. Just from calibrations, they're looking at saving up to $100 million a year. GM's journey here is a work in progress, I should tell you that. But they know where they're going, and this is where they're going. And the numbers, again, are pretty big. And was I going to say something else about that? Oh, the $100 million, that's just labor cost. So never mind the cost of an accidentally misconfigured car, a miscalibrated car, which could lead to a recall. Never mind that. So we're going to save that as well, and that'll, I think, increase the savings. Oh, and on and on. There's another one I like is over here on the right. This is about a leading avionics company. Their systems which control aircraft have to be certified by various government authorities, and it used to take them just months to create a certification package, big old Word documents. They would hand to a certification authority and say, here, certify our airplane, please. And now they can do it in about 3 days, and that, to them, that was an 8-to-1 improvement. Just another kind of shared asset, but the same thing applies as well. So there are more case studies like this, and they're all using this without copying form of product line engineering. It's called feature-based product line engineering. Here are the economics of it. Here's why these numbers are happening. First of all, under the old approach, the product-centric approach, where everybody goes off and works on the product that they've been assigned to work on, imagine you have a change that comes into your organization, and it affects, I'll pick a number, 5 members of your product line. Then what happens is, so it's this column right here. This is the one that applies. Each team that is affected by that change, each of the 5 teams will go off and they'll apply that change to their product. They essentially do the work 5 times. And I think we've come to accept this as normal. I think we've just come to accept this as, well, what else would you do? But to me, the ability to even ask that question, when a change comes in, how many members of your product line did it affect? That itself is a change in perception. Nobody would have thought to ask that before. They just would have said, you, and you, here's your change, go make it. But they never would have thought to ask, well, wait a minute, how widespread is this across our product line? And so work essentially gets done multiple times. Here is a different view of the factory. Bottom left are all the shared assets I talked about before. So now I'm using the traditional systems engineering V model. And they're all supersets, as I mentioned with Lockheed Martin. So pick your favorite part of the V here. This is obviously a, you know, a notional V. Every organization typically has their own. Pick your favorite part and say, whatever that is, I'm going to maintain it as a single superset, a superset. So for requirements, it's a superset of requirements. Every requirement's in there someplace for any product in my system, but it's only in there once. Source code, right, superset. All my source code is in there for any of my products, but it's not duplicated. It's all in there once. Test cases, right. Every test case that I'd ever need for my portfolio is in there. Each one's only in there at most once. It's what a superset is, right? You squeeze out all the duplication. Well, supersets don't cut it. A superset doesn't apply to every member of my product line by itself. I have to do something with it to make it, to sort of shave it down and make it actually apply. And that's the job of a variation point. And a variation point is shown in this figure by little gear symbols. And a variation point is simply a piece of content, whether it's a chunk of source code or a requirement or a test case or a chunk of a paragraph in a user documentation or a part or an assembly in a BOM. A variation point is just a piece of content whose participation in a product depends on the features chosen for that product. So hence those lines up to the feature catalog, which is the feature model for my entire product line. Well, that's it. That's the secret. There it is. I've given it away. It's the notion of a superset. And by eliminating all of the duplicate material, this is where the numbers come from. For each member of the product line, I'll build a bill of features. I'll put them together in the configurator, which will produce instances of those assets for each member of the product line. Here are the economics of that. This is where the numbers come from. Same scenario as before. I have a change that comes in now. It's going to affect 5 products. Maybe it's a new capability. Maybe it's a defect fix. Could be anything. But telling the same story as before, it affects 5 members of my product line. Well, you still have to do the work. Sorry, I didn't fix that. You still have to do the work. But now you do the work in the superset, or in the feature catalog, or in the bill of features. You do the work once, and you're done. Then the automation applies it in the other places where it needs to be applied. So you don't do the work 4 times in this example. This model is exactly how Lockheed computes $47 million a year. It's exactly how General Dynamics computes $830 million over 12 years. There's another thing that's going on here. There's a metric that's hidden in here, one that I think is pretty fun. General Dynamics counts, on average, where they fall in this graph. And it turns out in that live training transformation product line I showed you, on average, a piece of work comes in, it affects 2.8 members of their product portfolio. Let's round up. Let's just say 3. And so on average, a piece of work that their engineers do affects 3 products. General Dynamics claims, and I think reasonably so, you can tell me if you agree or not, they claim that their engineers are now 3 times as effective as they were before. 1 engineer is doing the work that 3 were doing before they went to this approach. So there's this kind of productivity scale as well that you can measure this way. I kind of like that. For reasons I don't understand, and I really think about this a lot, for reasons I don't understand, 300% is kind of what we see over and over and over again. 300% improvements in productivity. I don't know why that number is special. Someone said to me once, maybe 3 is the number of times it takes before engineers get sick of doing the same thing over and over again. Maybe. I don't know. If you think you know, tell me. All right, well, if this is so great, why isn't everybody doing it? It's hard. It's hard. This isn't just a technical approach. This isn't just a go out and buy a tool approach. If you want to do this, if organizations want to do this, they need to buy into it in ways like the following. They need to create some new roles. Somebody needs to own the feature catalog, for example. Somebody needs to own a bill of features for each of the members of the product line. There are new processes. We don't clone and own anymore. We don't make copies. We build things in the superset, so there are process changes as well. We want to see an organization adopt a particular organizational structure to do this. Customer interactions change. Now you can kind of nudge them into asking for a product that's either already in your product line or your feature catalog has already made accommodations for. I used to work for somebody, she had 2 kids, and she said as a mom, her job every Christmas was to make her kids want whatever it was she had bought them for Christmas. And I thought that was a pretty good description. Well, that becomes the job of a business development person or a customer representative. They want the customer to want whatever it is that they can provide. And this isn't about saying no, so you never tell a customer, I'm not going to build that. But what you can say to the customer is, we will build whatever you like. But if you take a member of our product line or something that's, if you choose from our feature catalog, you'll get something in, you know, half the time. It's already been tested. Its quality's up. Cost is a fraction of what you would have paid. But if you want your special thing, that's all right. We'll add the capability to our product line, but you're going to pay for the unique development it's going to cost to add it in there. You'll pay yesterday's prices, you know, not today's discount prices. So if this is so great, why isn't everyone doing it? You know, in some sense, this sums up my career. I've been writing for a long time about really great stuff, and I've always wondered, why isn't everybody doing it? And I guess I need to be happy that some people are doing it, and I am. I'll close my time with you today by giving you a little bit of news. The results that we're seeing from this approach, it's leading to an ISO standard. So there is an ISO standard in progress. There is a meeting in Helsinki, it was last week as a matter of fact, for the next stage of ISO 26580, which is methods and tools for the feature-based approach to systems and software product line engineering, because we couldn't think of an even longer title that would have been really great. But that's it. And so you'll recognize this is the reference model, and you'll recognize the fundamental motif here: shared asset supersets, the feature catalog, the bills of features, the configurator turning out instances, an automation-based approach to product line engineering without copying. And the layers on top, I think, bear some mention. I told you that this wasn't just a technical issue, it was a business issue as well, and the standard recognizes that. We talk about business organization management, what the leaders have to do to really get the most benefit. We talk about technical organization management, what the technical leaders have to do, and we talk about the technology as well, what the tools have to do. So, in summation, I think that change happens. I just do. I think that what we were taught 2.5 millennia ago is right. And we have a choice. You can ignore change, and if that's okay for you, then that's okay. Go in peace. But I think planning for change is better, and this is what I have spent a lot of my career thinking about. And if you plan for change, you are either worried about a single solution at a time, or you're worried about multiple solutions at a time. This is the world I live in. And if you're worried about this, you can build a super general solution. I love that. I think I'm coming down as a fan of the super general solution. Never mind the rest of the crap I said. That's awesome. We just need to build that. All right. No. Or you can build a product line. And there are 2 ways to build it. What I will call the first generation approach. It involved a lot of reuse-based copying, or feature-based product line engineering without copying, and that's where I live. So that's it. That's what I wanted to chat about this morning. This is a way in which change has led to the discipline of variation management, and this is a way in which variation management is manifesting itself in some sectors of the industry today. I appreciate you being here. Thank you. I'm happy to take questions. As I understand it, the protocol is walk up to a microphone.
Hi, I'm Vasco from the University of Montreal. Okay.
Thank you. Yes.
I have a small question. How do you see the engineering of these situations where, well, the system is evolving, so you update, you have little tweaks, and that changes for all your product lines and updates. What if you have a new feature that's requested, usually not security, but other things that you change, okay, and it will be updated, but what if that update breaks things for other sub-products.
Right.
So now you have this balancing act of the, well, when you copy, you branch out, and now they're independent. But how do you keep the system benefiting from this without breaking itself so often or discarding portions?
It's a good question. Let me see if I can paraphrase the question.
Sure.
A new feature is needed because I have a new customer, or a customer has a new need. Well, how do I add that without breaking what was already there? I think there are two cases. One is that this new, well, first of all, I have to add the new feature. I have to add it. Some customers are going to want it. Maybe it's just one, but maybe it's more. Never mind, it's all the same. If one customer wants it, then I don't care if more than one want it. You have to add the capability. So you have to add it to the feature catalog, and then add it to all of your engineering assets. You have to write requirements for it. You have to write code for it. You have to write tests for it, whatever your assets are. Now, for anybody who doesn't want that, they're fine. I don't need to do a thing for them. For people who do want that, then they also have to take the other changes that came with that. So that feature, that new feature, is going to go in the feature catalog, and people can have it or not. My superset is still a superset. So each of my assets, they have places that work with the new feature, or they have places that work with the things without the new feature. And so it's the superset paradigm. It still works. If you're a product and you don't want the new feature, you're going to get the parts of the shared assets that work without that feature. If you're a product that wants the new feature, you're going to get the parts of the supersets that work with the new feature.
We have a question back. One group. Yes.
Oh, hello. Namo from Virginia Tech. This is a little hard. So I have a question concerning your opinions about researchers' role in this software line production. As you mentioned earlier, this is kind of a business approach. It requires for the effort of the organization, process management, etc. As a researcher, I'm more curious what we can do in order to help improve this process.
I love that question. I love that question. And I think there's some very rich answers. So it depends on which part of the world, which part of the sort of problem space you like working on. As you said, there are business areas that are part of this picture. Well, organizational change is a discipline that has a lot of literature behind it. I think a lot more work needs to be done there to help organizations adopt a new way of doing things, whether it's this form of product line engineering or something else. So how do you most effectively get a business to most efficiently adopt this? That's a business-oriented research topic, I think. There are process-based issues associated with that. So if you like, process issues, this is very rich in those. In terms of technology, there are things like variation languages and variation point specification standards that people are working on. I think there's a lot to do there as well. So those three areas I mentioned, business, technical, and technology, I believe each of those has a fairly rich body of research topics. But I love the question.
Hey, Paul, this is Will Trace, your friendly used program salesman.
Will, my goodness, how are you?
Yes, hey, I wonder if you could address some of the technical challenges of your factory configuration, in particular, configuration conflicts.
Say some more.
In particular, you have a user who might want a single feature, but it conflicts with another feature that he wants, and how do you resolve that in your configuration process so as to either alert the user, the customer, that if you want this feature, then you're limited to these other sub-features because there's a dependency. And then I'll just turn that question on the end. Is there any machine learning that can then do reverse engineering to create a product line to understand those dependencies?
Research topic, machine learning to capture constraints among features. Let me answer the first question first. So So my answer is a little bit tool-centric, but I think a very important part of a feature catalog is the capturing of those constraints about feature interactions. I didn't talk about that at all, but it's huge. It's just huge. So if you pick this feature, you can't have that feature because it doesn't work. Or this is another kind of constraint we see captured. It works, but you're going to break the law. So for instance, you can't export that, or you can't give this material to that customer because you'll violate IP. So yeah, I believe that in the capture of a feature catalog, it's critical to capture those kinds of assertions. I don't think I answered your question except just to say, yes, you're exactly right.
Okay. Thank you.
Okay.
Okay, Bernd Brugge from Technical University in Munich. I'd like to expand on the Boeing example. The newest disaster, I would say, is the 737-8 MAX. And I'd like to think of this as a problem with the product line because they tried to save money in terms of training costs. So how can you improve, or how would you have done it with Big Lever? Would you have been able to fix this before the two major accidents happened?
Yeah, so how did product line engineering help or not help in the 737 MAX case? You know, I hesitate to say too much because I just don't know the details of that, and so I don't want to speculate.
They tried to save training costs. The pilots didn't have to be updated.
Right.
Because there was no major change.
Right. Right, that's right. That's right. I don't think that had anything to do with product line engineering except that people tried to take the product line and make its look and feel consistent across the entire product line, which is a good goal. But I just think they took that too far. It just seems to me like it was a bad decision not to. Oh, there were a lot of bad decisions. You know, one is to not inform the pilots. The second is to make the system rely on a single sensor whose input could be bad. That's just an engineering issue in it. And both of those could have been issues even if the 737 MAX 8 was the only plane that Boeing ever built. They could have gotten that wrong. They could have gotten both of those things wrong, even if it wasn't a product line. Certainly the product line contributed to the first one. They didn't want to make it look different. But the notion of having the software only appeal to one sensor, that could have.
Yeah, the double sensor, the redundancy was not taken care of. But could you not think of this as a shared asset superset, so to speak? Or one way to say, I mean, they have this double redundancy requirement for all kinds of systems, right?
Right.
And here they didn't because they wanted to save costs. Isn't that a fallacy of product line engineering?
Well, I don't see it yet, so I don't see the fallacy yet. We always want to save cost. That's the whole point of this. But when saving costs gets in the way of user satisfaction, safety, or reliability, then obviously that's a bad engineering decision. I'm sorry, I don't have a whole lot to say about that relative to PLE.
Okay, thank you.
Okay.
Hello, thank you for the presentation. I'm Abdul Razak from the Liro. My question is, when we add few features or we modify few features, this might be possible that already existing feature in the system may be cross-cut with the new features. So is there any paradigm of the programming available that can handle these kind of the issues? For example, I know one of that is based on aspect-oriented programming. And do you think that the people are adopting that? What is the majority of the research level in that paradigms? Like how we can add the features in the existing features, even by allowing that it does not interrupt if it is required the cross-cutting of with the features.
Can you help me with that?
I think the question is, what's the relationship between aspect-oriented programming and product lines? So, with
wow, was that your question? Cool. What's the relationship between aspect-oriented programming and product lines? The part of your question that I heard early and that I understood was, what if you get a feature that's similar to a feature that's already there? And I think that's not a technical question as much as an organizational question. So I want to see governance bodies in place that will vet new requests and vet them against what is already there. I think that aspect-oriented programming, it's a way to me, this may be a gross oversimplification, but it's a way to me to factor out particular properties about a system into one place that can then be spread out across the whole system. I think it's very analogous to features. I think that's exactly what features are. To me, feature is a refactoring of commonality or potential commonality among different systems in a product line. So what is the technical relationship? I don't know. But what is the conceptual relationship? I think they're analogous in some ways. I'd like to think about it some more.
Thank you.
Okay, it's my turn. First, thanks for the speech. I'm Yilong Yang from the University of Macau. I'm very interested about just like the feature-based product lines. So I'm very confused about one just like the new methodology about microservice and DevOps. It is also some kind of the feature-based or something. So what's the relationship between the feature-based product line with the microservice? Can this kind of the approach can apply to the microservice-based methodology? So I'm a little bit confused.
Right, so say it again. What's the difference or what's the relationship between feature-based product line engineering and
Microservices?
Oh,
Microservices.
So you get some of the same kinds of things where you build it once and then you rely on it, but at runtime rather than build time.
that's it. Yeah, that's it. It's what he said. It's the difference between runtime and build time. And you know, runtime management of variation, runtime handling of variation, it's okay. It's okay. Many organizations don't like that because for particular instances, I'll be simple, they don't like dead code in their systems. So that's a problem in some avionics systems, for instance. Certification authorities don't like dead code. So if I have runtime variation that a member of my product line needs to adjudicate, well, that's what computers do. That's what software systems do, right? It handles variation. If this, then that. If this, then that. But if there's variation that a particular system doesn't need to handle, it will never show up. Then there's some merit in taking all of that out of the system or never putting it in the first place. And so that to me is a runtime versus build time configuration issue.
Okay, thank you.
Hi, Paul. This is Rashina Hubble from the University of Auckland, New Zealand. Thanks for your keynote. My question is, you started off talking about change and variation, which is inevitable. You also talked or referred to the V model as a means to manage that change. I was wondering what you think are the synergies between agile software development, which is an iterative and incremental model, and something like PLE, which is based around change, and both of them being based around change.
Yeah, good question. What's the relationship between agile and product line engineering? Yeah, really good. There are a couple different answers to that. One is a conceptual thing, one is sort of a in practice thing. Conceptually, this looks agile to me. Conceptually, this looks like an agile approach to me. You tell me what's in, what I need, and then I will quickly produce it for you. And I'm agile in the sense that I'm flexible with respect to that. I've got a catalog of things I know how to build. So there's a kind of an in practice answer to this as well. Most of the companies that I see doing this, they're using agile. And so I would say that here's what I see the relationship is. This whole figure here, this PLE factory, that's the system. That's what I want to build using agile methods. That's the one thing that I want to build. It's the PLE factory, which itself has the capability to spin out instances of things. But I need to plan the development of this in an agile way. I need to structure the development of this in an agile way. I need to take ongoing care of this in an agile way, and I need to build this in an agile way. So to me, the strongest link, I'll say, between product line engineering and agile is that this is the thing that I want you to build, and I want you to build it in an agile way. That's what I would say.
So you're talking about using agile as a meta model wherein the PLE factory is the product that's being developed.
Exactly.
Awesome. Thank you.
Exactly. Yeah, cheers.
Okay, one more question in the back.
Marion Petrie from the Open University. Thank you for an interesting and example-rich talk. I was wondering about the relationship of PLE to innovation. And
To relation to what?
Innovation. So you're talking about feature-level innovation integrated into this, but what about radical innovation? Is there an inertia implied by this against radical change?
Yeah. Yeah, it's a good question. In that early case study I did about Celsius Tech, one of the things that that company did, which I thought took really good foresight, they built a technical steering committee, and this was composed of their thought leaders in the company. They said, if we're not very careful, then we will fall into a rut of only building these things that we know how to build and not building anything else. And so the technical steering committee took on the role of looking at new technologies, new customer needs, new trends, new industry approaches, and so forth. And it made sure that they were able to accommodate those. On a more day-to-day basis, I would say that many of the organizations I look at, they have business development people who go out and talk to a customer base. And they say, what do you want? So this is true whether the products are mass marketed and mass produced like General Motors, or sort of one-at-a-time systems like Lockheed Martin or General Dynamics. They go out and they talk to either the customers or the customer representatives who are, in my experience, not shy about saying what they want. And then they bring those requests home and they're vetted. They say, we can either do this or we can't do this, but let's, because it's cool. And in rare occasions, they say, we can't do this and let's don't. I've almost never seen that happen. So I think that's where the innovation that I see comes from customer needs. And the customers don't always say, I want a blue thing that's square and it's this big. A customer says, I'm tired of losing airplanes. Make me not lose airplanes. And then the organizations have to say, well, let's come up with a way to satisfy that. So I think there's room for innovation here, but I certainly think your question is a good one. Don't lose sight of it. And you can take organizational means to do that, I think.
Okay. There's one more question here, but can you be very brief?
Okay. I have been working with software products that are changeable or customizable by the end user. And for me, that was always very close to product line architecture. Just pushing the variability management to the end user. And I always wanted to ask you, how do you see the relation between the two? Software products that are customizable, configurable by the user and the software product line. And how would that picture change if it is the user who develops the final versions?
Yeah, okay. I don't know. How do you think it would change? Let's see. So I think you can open up, I can imagine that you could open up the factory and you could let the user, you could let the user into the factory. The way we add new things here is by updating the feature catalog and updating the shared assets and updating, if it's needed, the bills of features. And I can imagine that we could open up all of that to users, let them do variation management to the extent that they like. I haven't seen it. You can tell from my, deer in the headlights answer that I've never seen that, but I think it might be okay. It's a terrible question for me to end on. I'm sorry. It was a great question. It's a really good question. It was a crappy answer.
I think we can explore that further. We all know, use our mail readers and we all configure our filters so I think actually we all are very familiar with these systems. We just never think about them as very product and product lines.
Yeah. Yeah.
Well,
thank you.
Let us thank the speaker.
So
So Paul, thank you very much for
Thank you, Joe.
for your talk, and I hope that you will accept this gift and keep us.
That's very
in your
sweet of you.
mind.
I absolutely will.
After you go home, don't drop it.
I promise.
Oh yeah, you get to see it.
I do? Okay.
Or at least.
Should I take it out?
Uh,
Or no?
You don't need to do that because
Okay.
there's multiple
Right, got you.
things, but I think the photographer would like to. Exactly.
Yes. Yes, okay. All right, that's awesome. More this way.
Thank you.
Thank you.
Thank you.
Thank you, Joe. It's very sweet.
So.